Alright, this is section 4.5, question number 3, which is over L'Hopital's rule and figuring out what is and what isn't an indeterminate form. And so what L'Hopital's rule states is that if you have a quotient, and in that quotient you have a numerator that is continuous and differentiable, and a denominator that is continuous and also differentiable, and when you plug in the value that the limit is approaching, you get an indeterminate form, you can then take the derivative of the numerator on its own, the derivative of the denominator on its own, and plug in the value again. And what I mean by an indeterminate form is typically going to be 0 over 0 or infinity over infinity. These are two examples of indeterminate forms. And there are more indeterminate forms, but these are the only two that I can think of off the top of my head. And I think there's maybe some where you have like 0 to the 0 or 0 to the infinity or infinity to the 0. So there's quite a few of them, but the two main ones for L'Hopital are 0 over 0 and infinity over infinity. So for this limit, this is problem number 3, and asks us to find the limit as x approaches 0 of 7x squared divided by cosine x minus 1. So if we were to just plug in the value, this is the only way we can find if it's indeterminate or not. We plug it in. 0 squared times 7 is 0. Cosine of 0 is 1. Minus 1 is 0. So we end up with 0 over 0. So we proved it's indeterminate. So indeterminate. And therefore, I can apply L'Hopital's rule. And what that means is I can now treat this as the limit. So the limit as x approaches 0 of some function g of x over some function h of x. If it is indeterminate when I plug it in, then I can say that it's equivalent to the limit as x approaches 0 of g prime of x over h prime of x. And so in our example here, what that means is we're going to take the derivative of 7x squared, which is 14x, and divide it by the derivative of the lower square, or of the lower derivative, which is cosine of x. The derivative of that is negative sine of x, and the derivative of negative 1 is 0. So now we've proven that this limit right here is equivalent to this limit using L'Hopital's rule. So now what we do is we plug in our value again. So we're going to plug in 0. 14 times 0 is 0. And negative sine of 0 is also 0. So once again, it's indeterminate. And therefore, we'll use L'Hopital's rule again and use this same rule. So we take the derivative of the top all by itself, which is 14, divided by the derivative of the bottom. The derivative of negative sine of x is negative cosine of x. And we're taking the limit as x approaches 0. And with L'Hopital, as long as you can prove an indeterminate form, you can keep taking the derivative of the top and dividing it by the derivative of the bottom until you come up to an answer where plugging it in works. So in this case, 14 will stay 14, and negative cosine of 0, well, cosine of 0 is 1, negative cosine of 0 is negative 1, and so now we finally come up with a number, and so that is our limit. It's negative 14, and this is a pretty cool tool. This would be really hard to solve as a limit without L'Hopital's